Welcome everyone to another live stream with some media outlets reporting GCC or actually LLVM 16 being as fast or faster than GCC. Did I say LLVM? No, LLVM 16, LLVM Clang 16. Is it time to switch to that as a default compiler to one of the most popular Linux distributions? And so I did a quick test with my old open bench here that I started 15 years ago. Didn't maintain much since then. So I can't instantly, so as some news sites say geometric means, they run more tests and stuff. But if you just run a handful of good old gzip JPEGs, then the difference is not necessarily that large. So runtime, although here for JPEG, Clang is faster, for example. Gzip is, yeah, GCC maybe a little bit faster. Lame is LLVM not always faster, so you see the mileage may vary also a little bit. Some tests also exhibit strange performance characteristics. I noticed already earlier. MIPS and ARM also at times really strange performance. LLVM Clang hit for Lua depends on optimization, because obviously the optimization levels are not created equal. So if you compare O2 between LLVM and Clang, you get different optimization levels. But even for set standard, sometimes it's a little bit faster, sometimes not. Your mileage may vary. But it's certainly very good. And for me, it is more, so not that I would immediately see it is that much faster, but we could theoretically look at size. Also, let's quickly compare. I didn't even look into that before we do some work. So your build time, wow, this GCC is getting apparently really slow with higher optimi. So this is build time, right? This is how long. I'm surprised that Clang comes out so much faster. So that is unexpected. By the way, I run this with x86-64-v4. Where did yeah, version 4 on Horizon 1750X. So the build time surprises me right now here significantly. That is unexpected. It's much too. Yeah, I spent actually quite some time running this test because, as usual, my old test code here is not the most. But yeah, that would actually be LLVM Clang. So yeah, I mean at O2, but even at O2 GCC is, that is really interesting. So yeah, for Linux distributions that means a lot of work. Thankfully, we have already years ago live on YouTube tried LLVM Clang only systems. So I know already there are a couple of packages that currently don't build with Clang, namely glibc. At least the last time I tried, probably that is still the case. Why do they not build? Because too much GNU-isms, hacks and features. The Linux kernel at times, yes, I know there is a decade-long battle going on of making the Linux kernel build with Clang. Ironically, 15 years ago, the Linux kernel was capable to be built with Intel's ICC, proprietary commercial compiler back in the day. I'm aware some architectures compile better, like ARM is maybe upstream, x86 still probably not fully. Yes, there are probably a dozen of small low-hanging fruit patches to make the Linux kernel build with that. And last but not least, also grub, at least for x86 the last time I tried, did not build. So we have at least 3 major packages, right? What is your Linux distribution without glibc, except if you use Muso, Linux kernel and grub, unless you run ARM or stuff. So there's some stuff to do. Luckily, I have this, so I'm not using this cheap opportunity to make a live stream about this. I have actually on my to-do somewhere, which also too many terminals. I had on my to-do here actually LLVM Clang Gold, LLVM Gold plugin maybe, but more importantly, currently we lack Clang and Arch target wrapper stuff for our build system. So it's probably a good time to finally do that. despite all our previous work, but there's always one more thing. So even if it might also be that I committed maybe 90 or 95%. Some other stuff was probably not ready, too hacky and whatnot. So it's always like one more thing. Years later, even 1, 2, 3 years later, one more thing. And then, I mean, we can't even switch all architectures, right? GCC, LLVM Clang does not support all architectures. Whatever exotic Super H maybe, or IA64 and so on. So the question would be more, should we switch some architectures where it's mostly ready to Clang? Actually, I really would wonder what it would do to our build time. Maybe that's actually cheaper in terms of buying memory, CPU overclocking, undervolting, and so on. Let's take a final look at the sizes. So this is a resulting binary sizes. And so at I mean, it's relatively similar. At 03, Clang is, for this handful of tests, a little bit. So this is funny. For 02, LLVM Clang is often a little bit larger, inlining and stuff. Why is it different? Because it's two entirely different compilers, right? So obviously the compiler infrastructure is doing vastly different things, although they name it 02, but obviously entirely different algorithms and stuff, or not entirely different algorithms, but somewhat different and implementation specific. For 03, however, that turns, and Clang is in nearly all those tests actually smaller. That is actually interesting, and for fast even more so. I didn't benchmark size. I mean, I could actually, not while we talk about this, why not add multi bench, and then we get to do some. I didn't try LTO because this usually has some issues, and I tried it shortly. Of course, with GCC it mostly works. Package doing strange things. What have I done here? So yeah, with LTO that might be even more different. And of course for LTO we would need to add even more scripting configuration loads and so on. So people chiming in there, I welcome everyone. Interesting, still using GCC optimizations better than, well, so this, I mean, so I'm totally aware that Phoronix benchmarks a little bit more. They also have a benchmarking business. So in all of their geometric mean tests here, apparently Clang comes out a little bit faster. So it's not that simple anymore, right? Just this with my small subset. And so yeah, if we would, I should obviously, I mean, I just recently added JPEG, so this is a size though, but yeah, I'm aware that that's not probably one of the more complex things. I probably should extend that a little bit. Why do I do other things? I'm not the greatest fan of PHP implementation details, but actually it's also a win for the community. I actually did this in 2005 or whatever for Linux Magazine articles when everyone was using the spec suite for benchmarking, and that is, of course, it's heretically expensive benchmarking with Perl and gzip and whatnot. So actually I mimicked it a little bit after spec in 2005, just that I didn't really need it since then. But if I do some small benchmarking, I always come back to my good old little code here, because why not? I probably should add some bigger benchmarks like OpenJPEG, and at that day I actually had Botan and Trap3D in there, but probably I should extend this a little bit, because there's nothing like peer review, right? Always better to really check that the benchmarks are not measuring some funny stuff, having some third party. So yeah, I would call, I mean, this benchmarks here not out as the most amazing. This here look a little bit better, but better build time and compatibility. For us, it is always options, right? So it is even if it's somewhat similar, build time benefit would actually, build time improvement would actually be beneficial for me. And there is more. I really hate code duplication, so it actually bothers me a little bit that we need LLVM Clang anyway for Mesa, for Rust. So for me it would be even more of a win to get entirely rid of GCC, just not because I don't like it or whatever. For me, politics and whatnot, don't care too much, but simply code deduplication, right? For me, entirely second set of C and C++ compiler is of course pretty wasteful when all we needed then is LLVM for Rust, Mesa anyway, and then Clang and so on. And a little bit faster build time. There are multiple additional things though, so we would need to finish this compiler wrapping stuff and probably mark packages either no Clang, because theoretically, I mean, or do we want to? That is the question. Like, so one thing would be like, if you wanted that stuff builds, because some stuff will not with Clang, exotic and whatnot, old-fashioned and so on. So either, I mean, if you only have one compiler, then you can't do much about it. But for systems where we anyway have two compilers, for example, Firefox needs Clang anyway. So the only reason I have Clang currently in the default selection is for Firefox. And then we could switch between them automatically. So like no Clang or either GCC or whatever flags to switch between those automatically. Let's take one final look at the what camera video is overlapping. Yeah, with the benchmarks. Is they are not? I've seen that, but they are also not the super most. Yeah, that's thanks for that. But yeah, so let's generate this one more time. That's true. So my benchmark results are not the super most interesting. I just wanted to put them in here that you have some. Did I not? Where is my? Where is OS? No, am I in the wrong directory? So OS is runtime. Yeah, as expected, not that different. Lua is even faster than O2, at least here. So that is a recurring reminder that what I said. And build time. Actually, we could maybe size is more interesting. Can I make this? I can shortly move my camera as you already asked. Video capture, unlock there, move it, whatever. So you have it. So size, yeah, it's usually quite smaller, except JPEG. JPEG in general doesn't differ here the most. So yeah, that stuff works, size optimization, and it is, at least for Lua, faster. Otherwise it doesn't. Here, for example, even set standard, right? Clang OS versus O2. So much too, I always say size. I set this for 15 years. Size is sometimes faster because smaller code, less cache and memory clobbering, better cache and memory utilization. Yeah, this is why we have the smart optimization, right? T2. If you choose smart, everything size, because most code isn't run, and then hot files with O2 or more. And what is build time saying for that? Clang. So yeah, O size usually faster than O2 also here. Yeah, more inlining. So why is OS O size optimization usually faster? Because smaller code. Less memory, less data to process, less cache and memory to clobber. And even when LLVM Clang builds that, this is why this is overall a win for most situations. So yeah, build time. Yeah, interesting. So let's do some stuff. Which would be, so basically we are waiting, what were we waiting for? The other live stream I said maybe Python 3.12 or whatever, but in the reading, because on Slashdot it was like Python 3.12 release with whatever, and that was already wrong. But now I thought it's released soon, but now I realize it is not even soon. But where do we want that or whatever? I think I usually had it here, and it was quite okay, wasn't it? Actually, you know what? We actually need this flag that I was just talking about. if we want, because if we want Clang default except where it doesn't, then we actually need this. Actually, initially I thought maybe it's a nice to have feature, but actually it's a must have feature. Otherwise we can't ship this actually for. So yeah, how do we? Yeah, I mean, maybe it makes, because if we, so let's, this is also how this works, right? Design, software development stuff. First, you obviously need to brainstorm, make some plan, and think this stuff a little bit through. So if we think about this a little bit, like if we want to switch for Clang, potentially also for build time and so on by default, then we couldn't build a new subscription with the 3 or so packages. So if we also have other compilers, theoretically we have GCC or whatever that someone I knew from Germany once started, but I guess he has mostly abandoned it by now. There are also other compilers like TCC and so on. So I think it doesn't make sense to mark them no Clang. I mean, we could do that additionally, but I think it would make sense to mostly mark them must have GCC. That would be glibc, Linux kernel, and grub, and maybe more. And with that being said, I guess it's time to test build that. I can basically, or should I? No, let's not throw away all builds, because sometimes it's nice to have them as a reference. And config. Okay, that's a bit much. Yeah, classic thing of reusing args and autocompletion stuff. You need to edit more. So we have this option, of course, just that we usually don't use it. So both compilers are selected, then we can switch that to Clang. Actually, for the Linux kernel, we have actually a kernel compiler. So Fortran, we don't really use that yet. Let's test if that actually still works. It may or may not work, because I personally didn't even use it the most. But we anyway need to write some code. Let's see what happens. It may halt and catch fire rather soon. Let's maybe also btops this stuff. And so yeah, glibc that, so this might, so 0 glibc that might build, because that's not yet using the compiler. That is using that's only extracting the headers. So actually most of this 0 stuff is actually not the most interesting. But we need, yeah, there are actually quite some complications in the implementation here. We need to wrap Clang and Clang++ as system GCC. So it's basically all the nodes I made here already. And we need to, because this is a little bit tricky, so historically we didn't had to do that, because historically all cross and native stuff used CC, which is still the case here. So all this building stuff is wrapped in our sandbox, going through the compiler wrapper for tweaking, auto-injecting, and filtering arguments. And so the thing is that Firefox is not using CC but Clang. So, and we historically wrapped CC, GCC. The question is, where do we want to do that? So this GCC, the best would be to do that in the Clang package, obviously, because if you build truly without, I mean, it's a little bit tricky, because, I mean, maybe we factor that out here somehow, because this is a little bit too generic. This GCC. There is Where do we build that wrapper? Or maybe here, wrappers in. Files I rarely touch. So, because historically, obviously for 25 years we built GCC, and now we have the situation that Clang is nearly ready for prime time. It's like Apple shipping that for 10 years, and now 10 years later we finally consider it ready for prime time. I wouldn't necessarily, so native. Do we have Clang wrappers? Actually we have. Interesting. Okay, we have here actually some, okay, then it's better to actually add it to this file. So here we have Clang build wrapper. So if use cross CC, where is it even? Yeah, need to do even in our code, right? So basically I didn't tweak it for 15 years, and now I need to find how that even was. Where this was used. Build tools. So wrappers were. Okay, here we do some get reverted, get expanded targets, target chain misc name wrappers in. We have that twice. No, that's, oh, we also want, actually we're not building with all threads. So we are supposed to build CC, GCC wrappers for Clang and Clang++. I'm actually not sure if that worked. I'm also, so the next thing would be we actually, do we build, yeah, we built a cross compiler in this in any case, but I'm pretty sure I didn't see. Yeah, this needs some fine-tuning. So basically, we are not installing a arch prefix cross compiler here, and somewhere we do. Okay, so this will also not work. So yeah, there is so many details, right? Why do I make this video? So currently I have like, yeah, this is so tricky. So this code here is actually from here, and this will break. So this is super tricky, right? Because some of this runtime stuff. So yeah, it's way more trickier than even I think. Like, let's quickly do it, and then I forgot what 2 years ago we already enabled. Because usually the compiler runtime, unwind, libgcc, and atomics and stuff comes from GCC. LLVM Clang family has replacements, but they are also a little bit tricky and not as GNU extension full featured. And so I have here code like, if the default CC is Clang, then we build with compiler RT and stuff, but that also broke because the only constant is change and regressions, and they changed this to mono-repository stuff. So this stuff used to build 2 years ago, but it will not build anymore. So basically, we could probably, or what we should do is, did we build Clang already? Probably not. Let's Control C that for a moment. we probably further want to do if default compiler is GCC and not, by the way, do we need, does this, okay, this does not, it needs a space, and not package installed GCC, I would say. It's a little bit, the question is always on what level of detail do you want to implement all this stuff, because it's not the most readable in terms of, I mean, it is readable, right? Default compiler Clang, but not GCC installed. It's readable, but what we basically don't have better language to express if we are going to use compiler RT and stuff from GCC. But I guess it's probably readable enough. The question is how many other and there are so many variables, right? And that are also details that we would need to get right if we would switch from, like, disable GCC entirely, then we wouldn't have its STL and so on. I mean, we have all the packages, just they are, the LLVM Clang mono-repository not are a little bit of a pain to build, to be honest. But that should probably be, okay, now we are building LLVM. That probably should be good enough to use for now. I would hope. The question is how much stuff fails. Also, I mean, my system compiler Clang can build. Did we test C++ stuff? Yeah, that is the question. I mean, the only win-win of this stuff is, I mean, with each step, there are probably two win-wins. The first is incremental steps are easier than doing everything at once, and I tried doing everything at once. We made quite some progress and did build some ISO, but it was a pain in the ass, and in the meantime, Upstream broke it with their mono-repository stuff in LLVM Clang. The second thing is improving configuration, patches, and quirks and features in any case. So even if you're not shipping that, like small little fixes, improvements like this LLVM Clang default, but GCC still installed things and other minor things we might find. Plus, of course, testing that LLVM Clang. I'm actually really curious. So maybe yeah, I can. We cannot live stream that long today. We can give it maybe some 30 minutes, and I need to go and entertain my child. But 30 minutes, yeah, so the only thing is, let's do some other things, because right now we need to wait shortly for epic thread ripping Ryzen 1750X to thread rip through that. Firas Kalkana asks, I'm interested in comparing the ease of bootstrapping GCC and Clang. So I personally would say GCC is easier, or I would say GCC is a magnitude easier, because they have, not only is it decades proven, so it's basically 30 years of code, it's basically configure, make, install, plus lots of quirks and features for cross-compiling, cross-compiling stuff. I would call LLVM Clang much more difficult. The CMake, you need to know much more what you're doing. It's because GCC, configure, make, install, Clang, it's like you need to set all those CMake things correct. And in my opinion, this mono-repository stuff is even more of a pain to build, because with GCC, you get the STL. In this configure, make, install, you get libatomics, you get like half a dozen or a dozen support libraries, GCC, libatomic, and various other sanitization and nice to have and whatnot libraries. For LLVM Clang, my impression is they wanted to make it easier with their mono repository, where they similar to GCC, because LLVM has LLVM Clang, libcompiler RT, libcxx, libcxx ABI, OpenMP and whatnot, some other stuff that I forgot. And I personally found, I mean, in general, I like modular buildings. Not only Lego brickwork, but stuff. Welcome everyone. I like small little things that you can build. The only problem is with LLVM Clang, you need to set it up in a very specific order and stuff. Years ago, so I think they wanted to make it easier with mono-repository, but you still need to put them all in directories, and like, yeah, I would maybe even more than a magnitude order of difficult. I spent hours years ago to set LLVM Clang up, but they broke it again, right? And for me, it's also, they have individual packages, but now you need to build them anyway, mostly together. So it's, yeah. But share, like, and subscribe, we probably should. Basically, we built with our Linux distribution 32 or so variants of mostly GCC based, glibc and musl and uclibc. And I actually have also on my to-do, because as you see, my to-do is obviously rather infinite. My to-do is rather long, right? I actually have the dream target of GCC GNU-less example target, but just because, and I was mostly there 2 years ago, right? But I'm also sick and tired of working after others, people, constant change and regression. So I know that this mono-repository broke all this stuff for me, and in 2 years' time I was not motivated of like, yeah, you know, whatever, then keep your LLVM Clang mono-repository at Apple and who knows where, or Microsoft. So yeah, if that makes sense, otherwise leave in the comments below. Fira says, agree, it should be mono. So the problem is mono-repository, so you say it should be mono-repository. I actually would like small dependencies, right? You build the compiler and you build support libraries. It's not that difficult. The only thing is that it's all intertwined and stuff. And it actually, like, if in a Linux distribution you have single packages, like they are single tarballs, in my opinion, it should not be built mono-repository. It was previously possible, right? So then you don't have this, I mean, you can't really easily package it as single small packages if you need to build everything together, right? And it's like, but yeah, I mean, mono-repository would mean you don't have LLVM and the Clang package, but you would have one big LLVM Clang everything mono-repository packages, right? And I actually like that LLVM takes 5 minutes to build and Clang build takes 5 minutes to build, so, and then you build 30 seconds compiler RT and stuff. But the problem is a bit, like 6 minutes. Did I say 5 minutes? 1750x only 6 minutes 28. So for me, it's a little bit ironic that they probably wanted to make it easier, but then they didn't. Yeah. Plus it was working and they broke everything, and yeah. Most of the time, so make more comments there. Sticking with GCC for now, easier to set up, bootstrapping, self-hosting, custom distribution, targets constantly changing. So yeah, I mean, so LLVM Clang was of course new, but also 15 years old already in the meantime. But yeah, that is why GCC bootstrapping is probably easier, because for 30 years it was configure, make, install. Most of the time need to fixing chain of dependencies together to make anything useful. It's long runtime, build time, split mother, largest packages, useful. Yeah, so Clang. We probably, yeah, so as I said, let's see how we do this for GCC. We need to have here some custom scripting for, okay, we probably use transform program name, to be honest. Transform. We also have a custom prefix here for tools. Cross, where is even our program? No, we don't use transform program name. Or does, oh, where even looking at Arch. Here we use program prefix. Okay, we need some kind of program prefix, and what else do we? I kind of forgot why we did this cross CC, to be honest. Another thing would be, should we get rid of that? Because why did we did that? Or did we do that because where do we put the wrappers? That would be the question. So did we build GCC yet? So yeah, GCC we built. I have no idea really why we did that. Do we not have the better thing? Probably would be, here we have wrapper. So it can't be that, so basically why would we do that? I don't quite remember why we put this in the wrapper directory in this I'm somewhat tempted to change that and see what breaks. Maybe historically we didn't have a bin directory and historically we only had a cross CC directory. Or historically we had the wrappers in bin. I have no idea really. And I mean, it doesn't make sense to go through 60,000 years, 60,000 years, 60,000 revisions. Comments there. GCC has these build passes it needs to go through. It doesn't need to go through. You can disable bootstrapping, and I think we do because we expect. So basically, this pass is only to make sure that your host system compiler is not too broken and stuff, and build itself so that it's guaranteed to be built with itself or working. Basically, we disable that because we bootstrap. We expect our bootstrap compiler to be decent enough to be not as broken. And we only want to build GCC once and not build it 3 times. And also we build first a cross compiler and then a native compiler anyway. So it's basically T2 is kinda bootstrapping that anyway with a stage 0 cross compiler and then a Canadian cross compiler. So it's kinda why we optimized 15 years ago already to build GCC only once. And maybe is there a disable bootstrap. We build a cross compiler in stage 0 and later we don't got GCC, so no bootstrap stuff, just if you wanted to know. But that's basically 25 years of Linux experience here of creating it so that our stuff works the best. So basically, yeah, cross CC. Let's probably disable that here. Not sure. We reset. You see a bin, and here is linking. Basically linking arch prefix. Where do we link that to? Okay, that doesn't matter. That could be any path, so that should be then bin. And here too. I guess that should be it. Was it cross CC, right? Okay, there we have, oops, I have 2 more. We might have the same for bin utils. Maybe we have, yeah. I guess that should be bin. Yeah, we also built this with a program prefix. Or can it be that, no, it can't be that for native builds, not to mix this with the system? I don't know, it also doesn't make the most sense. Ah, whatever. It should be fine. Let's see what breaks. Oh, thanks for the super chat. Highly appreciated, as always. Yeah, appreciate all share, like, subscribes, and so on. Patreon supers. So yeah, let's get away with it. I wonder if we have special cross CC. Yeah, we have. Let's see. Maybe we find some comments here. Cross CC. Use cross CC and then. Okay, so apparently, but this also doesn't make the super most sense. I mean, I'm only ruining the build now a little bit. Because I'm, as usual, editing around here. But, so the bin, so the tool's bin path is always in there. So I guess we could remove that fully if we always have the cross CC in the bin path. I mean, the question is if we SVN blame that for 60,000 revisions. Do we get anything interesting? Let's rebuild GCC and bin utils, so that would be x86, 64 tools and stuff. It basically deletes this cross CC. Or maybe I should have looked into it before I did that. Yeah, but now it's done. GCC, by the way, do you use... Yes, it is fully visible. And let's rebuild that without this cross CC and let's see what breaks. So cross CC. Kids, so this was changed. Ah, right, so this is only changed because I changed the stage levels. We could reblame that starting from that revision. And what do we have now here? Yeah. Oh wait, wrong. Oh, did I not blame it? Did I not edit this quickly cross? CC. Okay, this is here some revision. So this is really, really old. Now we are in probably 2003 territory. 2005. Oh, this is just some rename. Thank you very much. Yeah, that is all tree white raw config rename. Yeah, so now we are in revision 1 territory, so revision 1, thank you very much. So this basically was here forever except this revision. Let's see what... Carefully substituted or occurrence of work to tool chain. Okay, this is another tree white. Okay, so, oh no, this is Clifford, Claire, in, okay, okay, now we are 2003-ish? 2004-ish. Yeah, this is kind of stuff that drove me crazy also, like inserting here directories for no good reason. Why eventually, this is exactly this kind of stuff that's like why, it's also too big of a change. And it's like, yeah, this is my life then back in the day, 20 years ago, trying to make Linux distribution one of the most amazing, and then other people constantly like, let's randomly YOLO there some stuff. Okay, so this introduced here some rock things, thank you very much. So this was basically even maths. It's like, it's for 20 years like that, who knows, whatever. I mean, the only thing I could think of is avoiding name collision with crosswords of native and wrappers and stuff, but we have a wrapper directory, so I guess it makes most sense to have all compiler binaries in like one bin directory and wrappers in some wrapper directory. And so I guess we can, I wondered for years if we really need this, and keeping stuff simple and streamlined. Only the wrappers. The only question is, are those wrappers, do they have cross-CC hard-coded? Apparently not. We probably should make a tree-wide grep. So you know it's here where we wanted it. Probably makes the most. Also now something failed. CC not found for some. This is what. So yeah, now we don't have a compiler because we switched to Clang. So much to that. So yeah, now becomes a bootstrapping nightmare. Do we have a Clang compiler? Yeah, what time do we have? I also need, we still have some minutes. There's so many comments. People want more of my streams, that is amazing. Get some packages together for... invited 5 packages, 2 package LLVM and all its modules for obscure architecture would be fun. Alexander would like to have more Rust and Python packages to developers to package their own toolchain. Yeah, thank you. Exactly. Just use. So yeah, the problem is with Rust, you can't use Rust up to, like if you're a Linux distribution, you want to have more control, not like Rust up doing some random stuff, especially if you support non-mainstream architectures, which is why we, and of course the general not wanting to download other people's binaries and so on. So yeah, this I would need to check what even is going on there. Let's see if this cleaner thing is totally, this is actually totally clean. Cross CC, how often do we find that in, there's actually some parse this I just edited away, I guess. Maybe here is some, maybe this is breaking the build parse cross CC. Or did I remove that? I was probably just considering to move that. Okay, we need to adapt that, so this is to arch prefix CC. It's a little bit, can we maybe, so this is using fancy tools, but even more, darn it. Yeah, cross, there was some tools here. I guess this is probably what failed the build. Do we have a Clang there, or? So yeah, this is probably why the build failed, and exactly the stuff we are here for to fix today, or improve, fix, whatever you want to call it. We are like Apple. It's not a fix; it's an improvement. It's a quality of life and usability improvement of stuff. A new supported configuration. It's never a bug. It's not a bug and not an issue. It's just something of that sort. So what we would need to do for Clang, and that is the question. Clang. We basically probably, not basically probably, we basically want to link Clang to x86 stuff, and yeah, we don't have that, and plus it's probably what we need. And maybe that. So of course we need to automate that, right? First I want to see how far the build is going. And then so basically, so this was previously so creatively line wrapped. In the meantime, I'm not 80 columns or whatnot. Like basically, I mean, this is supersized for YouTube live streams. Otherwise, could read it less. Whatever the size was previously, something of that sort. So I'm basically like, I mean, in this size, that's basically like 100 columns or so. Fine with me. Okay, that failed. Okay, so cannot compile. So this is GCC. So this is also funny. Whatever that does. Let's quirk that by changing the default compiler for a test second, just to the default CC. It's just built over glibc, so for that we would need some automation. We could also, we could also check the usual win-win of Googling some minutes to find if there are glibc Clang patch or whatever. When can we build glibc with Clang? 2 years ago. Here is something. Here's some build in VA Yeah, however many patches are. Yeah, but if it's dozens of patches, then it's like, yeah, you had me at dozens of patches, right? Oh, okay, wait. This we also need Control C that prematurely. I wanted to check how many. Okay, pass config. I need to be careful to commit that. Maybe I should actually commit this here in this cleaner tree. And so GCC is the question I would think GCC should build, so let's switch back to Clang. Let's see if GCC, of all of GCC builds with Clang. I have no idea. I don't know what happens now with all the support libraries like libatomic, libstandard, CXX. Yeah, we will see. So yeah, let's redo that here in this clean tree. Then we can. By the way, right now we have no changes cross CC. So we do redo that just to have the comfort of this was bin. This was straight bin. This here was kind of superfluous anyway for that. I wonder, do we need to prefix? I would guess that should be set like that, so let's delete that. We probably might need to redefine it there. I guess I should wait a bit of the bit. I mean, I don't really quite. I mean, both was in the past. I really don't. I mean, unless you build without a cross compiler and then, because then you get like GCC. I don't really quite see a reason why we did this, but whatever. Alexander says distros are the source of truth on how things are built. No binary plops were. Yeah, this is why I'm not the biggest fan of this Rust C and stuff. We give this a moment and then we might need to optimize Clang though. Clang LLVM Clang. Ah, this is even built. I wonder now if that compiler error reporting is too harsh for WError. No. Even setlib fails. Okay, fine. I also need. That's off to a good start. But maybe that could. No, I have no idea whatever strange stuff that is now. We have X-trace on. I hit command wrapper. So it complains about not having that here, so we might miss a wrapper for that potentially. Not sure what exactly is going on there, but that doesn't. I mean, it's funny that the rebuilding GCC deletes the wrappers. Maybe that. That's the stuff that we need to script for that to fully work. Does this, by the way? GCC installed. Actually, we have a Clang wrapper. Did I copy that, or how did that get here? Command wrapper base name. Did I not zoom link that? Did something delete that? Ah, here, no, I zoom linked it wrong. Probably press tab, didn't look, and yeah, so ideally, yeah, we don't, for cross build, we don't want to have this installed as Clang, so we definitely need to fix this, because otherwise we would, like, if, yeah, otherwise we shadow the system compiler. There is even other CC. Oh wait, this CC is also theoretically wrongly linked then, but yeah. I guess we should build with Clang, shouldn't we? I mean, maybe we should remove that. That probably should also not really be used, to be honest. Anyway, let's see what happens. No, still doesn't work. Okay, F-full program isn't supported. Okay, that's the thing. So yeah, then now the so this we can't of course commit. So there the complications start. How to really tackle that? Because like if you like, yeah, 2023 or 2010 already, you have two compilers and both understand different arguments. That is, of course, yeah, not ideal. Okay, unsupported argument for FLTO, thank you very much. I mean, we could probably so for now, we commented out for a test. This is threading of how many threads to use for LTO. I wish in this kind of things, I wish LLVM Clang people would just support the same arguments. For us, we probably, I mean, we can conditionalize that. Like if GCC, then that's the only problem is like, until today, we had like one default system compiler and that was used. Now I want to change that a little bit, but that also means if we mark some packages GCC only, then yeah, everything becomes crazy complex, right? I mean, it sounds so simple, but then it's also such details, and we need to dynamically switch that, and then like even if we switch dynamically for usually the default is Clang, except it's a GCC only package because plus if you accidentally or other things run, for example Firefox, right? In Firefox you currently would have both. So, theoretically Firefox only supports Clang for stupid reasons, but it still builds fully with GCC. We do that because it until today was our system compiler. And for Firefox it would even be, it can be built with GCC, but behind our back they anyway will run Clang for some things, cbind and whatnot. So like, yeah, that is super annoying. I mean, we have theoretically GCC and CC and C++ and stuff, and so theoretically we could actually fill all those bloody variables twice. Okay, now LLVM also fails for some reason. Do we need to build so this? We need that for Mesa. Why does this now fail? LLVM fails building itself. It might simply not find some C++ thing, most likely. So probably it's not finding GCC STL for some parse lookup and whatnot. Also should go sometime soon. Yeah, I go now. Yeah, of course, lib standard CXX min stuff. I mean, I will do this later. So that is the Canadian cross compiler. Did I touch that? Ah, I also touched that wrong. We need it for Mesa though, and the question is maybe all C++ stuff fails now because, but that's another win-win, right? Not only supporting, like, yeah, if you don't update that, it like bit rot, right? What built 5 years ago might not be suited for tomorrow. And so the win-win of keeping this stuff maintained. There's also all the effort that goes in keeping all the stuff maintained, right? Well, if you did something 15 years ago, doesn't mean 15 years later it's still super amazing. The world, especially the IT world, all the tech world doesn't stand still. And yeah, I wouldn't be surprised if all the C++ stuff fails now with wanting an STL and looking somewhere where it's not. But yeah, that's a win-win of keeping all those details maintained and stuff. I hope you enjoyed this and liked it. Until now, I have to go. Don't forget to share, like, and subscribe. Most likely this is C++. Let's see. Get text, or is that some incompatible initialization obstacle? So like, yeah, 2023, more building your stuff. Yeah, that is, yeah. You build stuff with Clang and that's all you get. It's probably easy to patch. Just one more. Yeah, a properly working system and building everything just one. As usual, just one patch and one to do today. So patches welcome. Have a good day and night, and see you soon for more such fun to come. And have a great weekend, as Alexander says.